Okay, so basically in this tutorial we will see some DevOps related work. And when we talk about DevOps, basically it is the automation of the things like like suppose a developer is doing certain work or is working on certain piece of code basically, and if he commits something into git biz, so starting from building the overall compilation and everything, and then it will promote to certain environment, let's say QA, and then there the automation of testing will be done, and then finally the code will be deployed in the production. So basically nowadays in DevOps is getting used very frequently and heavily basic into the production pipelines mostly. Okay, so I mean, though the manual intervention will still be there. It means that it's not like you will allow to commit everything, directly to the production. Okay, because that is somewhat dangerous. Uh, so the tools mostly those are actually getting used for DevOps are like you might have heard about Jenkins, right? So Jenkins is like mostly do the automation of this kind of stuff, where it will help you to build the things automatically, promote it to the next level. There it will start testing automatically, and then finally it may promote the whole thing onto the production. So one more tool that is now being utilized heavily in creating such kind of pipelines, is GitLab. Okay, so GitLab is again a kind of repository management. Plus, it will also it is also having one thing called GitLab Runner. So this GitLab Runner again, it is the way that will help for in the GitLab environment, within the GitLab environment, to provide you the CI/CD CI/CD functionality. Okay, so when we talk about GitLab again, so when I say GitLab, there is two words, that is Git and Lab, right? So basically, Git, what is Git? Git is nothing but it's kind of a versioning control tool, where you can have the complete repository created in Git, and then multiple branches created out of it, and then multiple developers may work on different branches and try to do their individual work and try to merge them finally into a big product. Okay, so we will see all these activities while installing GitLab Runner, and try to create our own CI/CD pipeline. Okay, so when I say CI/CD, again, these are like two words, CI-CD, I can say. So CI is said to be continuous integration, and CD is continuous deployment. So it means that continuous integration, continuous deployment kind of pipelines we mostly build. And apart from that, basically nowadays, there is one more important thing getting utilized heavily, mostly in DevOps pipelines, or to create the applications or to run the applications in very container specific way. That is what is called Docker, Docker, Docker. So again, Docker is again a technology that will help you to run multiple containers on the same base operating system. Okay, so we will see some overview also of this Docker, like how does it work, how it is different than the virtual machines or physical machines, and how it will make your task or anything development much faster, and then how you can utilize it basically. We will also try to check if no sorry try to check if we could see Ansible. So Ansible is again one more tool that will help you to create some script. If you fire that, it will do multiple things, it's like configuration changes. It may install certain softwares automatically. It may help you to uninstall certain softwares. It may help you to change the configuration on the multiple machines simultaneously. Okay, so Ansible is again a quite heavily used tool nowadays in mostly automation purpose. Like suppose if you are creating, when we talk about like say this kind of activity more done in the big data world mostly, where you have multiple machines available, multiple machines are there in your cluster, and you want to do kind of running workloads related to machine learning or analytics, or try to do some migration projects where you will bring the data from some external world and put it into your distributed storage. Okay, so there you need to customize or optimize multiple machines. Let's say 100 node cluster of Hadoop or big data. So all these 100 machines should be having identical configuration in terms of configuration files and the available softwares and everything. Okay, so when you prepare all those machines, you can just use this Ansible to automate much of the configuration management as well as installation of software, then make them up and running. So within a single playbook running of Ansible, you can create a live 100 node cluster on either Google Cloud or in any cloud-based platform, or within your in-premise, okay, on actual hardware. So what we will do today is basically, we will go on Google Cloud, create our own virtual machine basically, and mostly we will use Ubuntu 16.04, that is the Linux version. Though you can use whatever Linux that is favorite to you, or you either Reddit based or CentOS or SUSE even. So all those flavors of Linux you can utilize just to do all these activities. Okay, so the overall intention is to create a GitLab environment and try to set up GitLab runner. And these servers, let's say I will say GitLab server, I will just write it over here. It is said to be GitLab server. And then we will have GitLab runner. So this two we will dockerize, this first one, and the second one we will dockerize this. Okay, we will run a Docker container for GitLab server and GitLab runner, and basically we will then access it over the HTTP and HTTPS protocol. So we will see that how you can customize, or how you can create your GitLab server that may run on either HTTP protocol or HTTPS protocol. So mostly HTTPS protocol is more secured one, that will be that will be preferred on as like a kind of production installation of GitLab server. Okay, and then finally we will try to create a kind of pipeline and see the execution, overall execution of it. Okay, then later on we will also cover that, okay, how you can set up your GitLab server running on HTTPS just by built-in certificate generator that we can utilize, or you can also have some external certificates to be installed on GitLab server, so that it will be working in the secured mode. Apart from that, basically we will see that how you can register GitLab runners and what is basically GitLab. So we'll try to see more insight about each of these mostly. So Ansible, we will see whether we can utilize it in this tutorial or not, but basically I will explain, or we can we can see that whether we can utilize this Ansible to create some, or some kind of activities to be automated. So let's go ahead, and first thing that we will do, and we keep on discussing all these fundamentals, and we keep on discussing each of these utilities or tools, and then we will see that. Okay, so basically now what I will do is this is my Google account. Okay, what you can do is you can have your own Google $300 credit free. You can just use your Gmail ID, have a credit card registered with it. Only 1 rupee will be cut, and then again you will get a credit back. So basically you can have a complete $300 credit free for the whole 1 year to utilize and to do multiple to do practice on this one. Or you can have your own local machine setup also you can do the thing. But to perform this, basically I am going to use this Google Cloud Platform. This is my login ID, and uh, now basically this is my console, I can say. So on that navigation menu, once you log in on your Google Cloud account, basically you will get a console option over here on the right top. You just need to click and then you will get here. Over in the navigation menu, basically you will have multiple services like products. If you see all these products, so you have compute services, you have storage services, you have networking services, and some more. So mostly we just require one virtual machine for our purpose, for our overall things to be performed. So I'm going on computer engine. Basically this option I'm heavily using it, so that's why it has come on the top. But basically when you go for the first time, you need to go here on compute services, and here you will find compute engines. There you need to click on VM instances. So basically you got on this page. So there is already one running machine called Ubuntu. So there are some certain things already installed in it, so I'm not going to use it. I am going to create a new instance. So I will say create instance, and then I will put here Ubuntu. I will say new hyphen. You cannot have underscore. So basically Ubuntu new, and let me just create this on default South Asia East one, Asia Southeast 1B. I'm going to have two CPUs with it for this machine, and I can increase the RAM up to 16 GB. So I'm going to use this 2 CPU and 16 GB RAM. Then on the OS selection, you can go over here and select this Ubuntu 16.04 LTS. Okay, and then amount of hard disk I am going to utilize is, let's say, 50 GB. I think it is enough. And then to select, then I have allow HTTP and HTTPS. One thing that you require is to have your public and private key pair that you can generate, and then on this security level you just need to enter that public key. Okay, so how you can do that is just basically go on putty gen. Now this putty gen exe, basically it will help you to create a public private key pair. Okay, so I already have generated and let me yeah, so I think it is this one. So this is my public key, okay, that I already had generated, and its corresponding private key I have saved it on my desktop as Google. Okay, this is the private key offer. So when you go on Puttigen, basically you can just do say generate, and then keep hovering your mouse pointer over here in this area, and then it will give you this public key. So this is like kind of a new public key, uh, and then you can save its corresponding private key onto your desktop. So just click on this save and give certain name of it. So it will be saved as .ppk. ppk, the full form of ppk is putty private key, right? So in your case, if you try to do this, just install puttygen in your computer, and then try to generate a public and private key pair like this. Okay, what you just need to change here is your name of the account ID that you are using for Google Cloud. So in my case, it is Mimant31. Okay, so if you see here, my login ID is Mimant31. So the same ID you can utilize whatever you are using. Let's say if it is xyz@gmail.com, so you can just put xyz. Okay, so it will create a public and private key pair for you. So I already have it generated, so I will utilize this one. So I will put this public key over here. Okay, and that's it. So this Ubuntu new machine will be up and running in 1 minute. So I'm going to create this, and now there are two IPs associated with each of every machine that you create within your Google Cloud account. So first one is internal IP. This internal IP is reachable within internal to Google network. So let's say there are multiple machines you have in your Google account. So all those machines will be able to communicate with each other using this internal IP. This external IP is just to reach to these machines from the external world out of this Google network, right? So if you try to ping this from your local computer, no, you are not able to ping it. But yes, if you try to ping this external IP, yes, you should be able to ping it. So if I just copy this and go to CMD and try to ping this, so I should be able to ping this IP address. This is external public IP address for my machine. So I will utilize this to connect to my machine over here, which is running as Ubuntu new. So let me go on putty and put this IP address. And while connecting, you need to select on authentication and browse the private key, that is this one, and then open. So first time it will just cache the public key, and you need to connect by providing your ID. So this is the let me change the appearance so that it will be bigger, and I will also change the color. Okay, so this is a new machine, right? So if you do host name hyphen app, it will tell you some host name. We will set this all up. Now, first thing that we need to do is to install Docker on it, right? So what we will do is, instead of installing the softwares directly on our system, we don't want to use this base machine to be the host, like not host, basically I'm saying we don't want this base machine to utilize to install the software directly on it. Okay, so we will utilize Docker and create multiple Docker containers. So Docker containers are like kind of an individual entity that will not affect much and keep your host machine intact. What we do is to follow this document. Uh, okay, so before we start installing the things, basically, you need to understand basically what Docker is, because we are talking much about like Docker. So we will just go a quick overview about the Docker. How does it help? So so basically, let's say if we are having this machine. So I will say this is machine one. Okay, so sorry for mistake. I will say this is my machine one. Now, it could be any physical machine. Either it could be a Windows machine or Linux machine, let's say, but it is it is having its own CPU plus RAM plus hard disk and all, right? So the base hardware is occupied by this machine M1. Okay, so let's say I have Windows running on this machine one. So what happens generally is we have a kernel associated with every operating system. What this kernel? Again, kernel is a piece of, you can say, software that will help you to communicate between, or that will help rather OS, that operating system, to communicate with the hardware. So whatever you do on OS level, it will be converted into the machine instructions, and that machine instruction will be then executed on your base hardware. So this kernel, like I can say that this particular kernel is sitting on the top of your hardware and give a kind of so on base, basically over here on down here you will have CPU plus RAM plus hard disk and everything. Okay, and on the top of it you will have the OS setting, operating system. Okay, so whatever you do in the operating system, with the help of that kernel, it will be getting converted into the machine instruction, and those machine instructions will be executed on top of on your hardware, right? And ultimately the result will get back to the OS. So it is completely, so kernel is mostly transparent to the normal users, and they don't think about it much. Now what we can do is on this OS, basically, if I make this OS bigger, there are ways to create multiple machines within the single OS, right? So I can just change the color, and let's say I have operating system OS over here. So within OS, I can do install, I can install VMware or VirtualBox, right? That VMware and VirtualBox are the you can say software that will help you to virtualize, that will help you to create virtualized environment. Okay, and in that virtualized environment, you can have independent operating system. So you can create one virtual machine. Let's say I am saying one virtual machine in which Linux is installed. You can create another virtual machine where, let's say, you have Windows installed, and so on. You can have multiple virtual machines running within the same OS, but again, it depends on how much hardware do you have at your base level, because each of this virtual machine will require certain share of your hardware so that they can work. Okay, so with, let's say, 4 GB or 8 GB of RAM, basically you cannot create more than one or two virtual machines on your system. Otherwise, the RAM, the RAM utilization will be definitely overshoot, and overall system might be dead or very slow. So what I will do is, uh, when we create any virtual machine, so we'll talk about, I mean, what we are trying to discuss here is to check like what is Docker, and I mean, and why the Docker has basically evolved, and how does it help you to uh, you know uh, uh, how does it help basically to avoid or prevent certain things that those are actually kind of disadvantages to the VMs, virtual machines. So before Docker, basically I mean, again, before Docker, we had a lot of virtual machines to be created on the same operating system, and each of that virtual machines have individual operating system where you can just work, right? So when we talk about any virtual machine, so let's say I created one virtual machine over here, VM. Again, let's say this VM is of type Linux. Okay, so when we install this Linux VM, it has its own kernel. Okay, so this is kernel of Linux, I can say. Okay, because this VM will have this Linux installed within that, and we have several such VMs. So I will just say this is VM1. Okay, that is of type Linux. You can have several such VMs depending on how much hardware do you have on your base operating system. So this kernel itself takes certain amount of RAM to be, to get the things executed for you. It means that this kernel requires its own share of hardware in terms of CPU and RAM, where it will start converting the instructions from OS into the machine instructions, and then get them executed onto the base hardware, and then get the result back to the OS. So if you have several such machine, the part of kernel, the hardware that the kernel is using, it is like kind of a vestige for, though it is required within VM, but basically we already have one kernel available over here that is of base operating system. So we are not utilizing it in this particular approach, right? We are creating our own kernel when we try to create our own virtual machine as a Linux. And when this kernel gets installed within VM, it is actually the vestige of the resources that you have on it, because we already have kernel available on the base hardware. We can utilize it some if but yes, in the very earlier days before Docker, there was no way to do that, and then we had to use this conventional approach of creating virtual machines, of having its own kernel, and try to do the things. So let's say one Linux kernel itself may take around 500 MB to 1 GB of space, or RAM actually. 500 MB to 1 GB of RAM, it is alone required only for this kernel. Again, rest of the things you can then utilize for the OS and all. So when we talk about Docker, this approach is changed somehow. And when we talk about Docker, what Docker will help is to create a VM. So still the VM would be there. I will say this is VM1, but it does not have its own kernel. What it will do is it will directly communicate to the base hardware using the kernel of your local operating system. Okay, so this kernel is, let's say, belongs to Windows. No matter which operating system you are installing in VM1, okay, it uses the kernel of your base operating system, and then it will uh, it will be very lightweight then, because the whole kernel itself is a very big piece of software that gets installed with the operating system when we create any virtual machine. So if you just remove that kernel itself from the operating system point of view, so a lot of space will be saved, and a lot of RAM will be saved, a lot of CPU processing will be saved, and then this becomes very lightweight. Okay, so I can instead of saying this to be VM, I will say this is set to be a Docker container. Docker container. container. Why is it said to be container? Because it has its defined boundary, and that boundary itself is said to be a container. Okay, it contains something within. So in the Docker container, what you have is a kind of OS, yes, but not the complete, not the all features of operating system you are installing. Okay, whatever is required, only those things you will have to make it more lightweight. Because when you go with the full installation of VMware or on any VM on Oracle VirtualBox or VMware, and we install a complete Linux image, so that Linux image is very bulky, and because all the unnecessary software also get installed, because you have to have it, because you need to mount some ISO and then install the complete operating system from top to end. Everything should be there. But here in Docker container, we install, or we have only whatever is required. Okay, so it is a very lightweight image. It may never run more than a 300 or 400 MB of or something maybe in 100 MB, 50 MB, depends. Okay, so you can just create images. You can just create Docker containers, and then basically run the things on. So instead of creating, let's say, suppose if uh, when you use VirtualBox or VMware, and let's say you can create only two VMs depending on the hardware you have on your base machine. So out of that, you can at least go 4 to 5 Docker containers running simultaneously with the same amount of hardware. Okay, so it is more, you can say, customized, optimized, and more efficient way of virtualizing the things. Okay, so that's how the Docker now gets famous. And you can have multiple Docker containers running. Each container has a kind of specific application with some basic OS and its utilities installed in that, and then it will give the services right out of the box. Okay, so now in the next section, we will install this Docker on our machine and try to see further more things related to the Docker, and then we will create a GItlab environment. Okay, so let me stop it here.